Let's go to compiling. So to compile and link with libraries. And here we're going to learn about the compilers at HPC2N, how to load the compiler toolchains. We have already talked about that. How to use the compilers, what are the popular flags, and how to link with libraries. The installed compilers. There are compilers available for Fortran 77, Fortran 90, Fortran 95, C and C++. The compilers can produce both general-purpose code and architecture-specific optimized code to improve performance, loop-level optimizations, interprocedural analysis, and cache optimizations. So first, before you can do anything, you need to load a compiler suite and possibly libraries, depending on what you need before you can compile and link. You use MLAV, as we just saw, to get compiler toolchains, and then you load one the same way as you do every other module. So let's try some of these things out. And we are going to be in the exercises simple directory under the intro course that we got from the Git clone. And in this example, let's go with FOSS 2023B. So let's just load that again. I'll just check I don't have anything loaded. I'm loading it again. And I have it. Good. And then let's go on to compile. Note that all compilers has OpenMP included, so it is enough to load a module for a specific compiler toolchain and then add the appropriate flag. Also, if you compile something and you don't name the executable, and you do that with the flag -o, whatever the executable should be named, it will as default be named a.out. The problem with that is that the next time you compile something, if you also don't name it, it will overwrite a.out. So it's a good idea to give the executable a name. And to compile with GCC, here are a list of the names of the compiler. It's a gfortran for all of the Fortran language versions, and it's GCC for C and G++ for C++. For MPI, there is MPI F77 and MPI F90, and there is MPI CC and MPI capital CC. There's none for the Fortran 95 MPI. And in order to access the MPI compilers, you just need to make sure there is an MPI library loaded with the compiler toolchain you picked. And FOSS 2023B indeed has such a library loaded. So let's go ahead and please code along. We'll try to compile a C program. And in this directory, let's call the exercises simple under the intro course library that you downloaded with the Git clone. There are several batch scripts and also several programs. And in this case, let's look at the hello.c one. And it's just a very simple serial program that outputs hello world. So let's try compile it, and we do that with GCC. I can try and move these up a little bit, maybe. No. So GCC, and then the file that the program we are compiling, which is hello.c. And then I am creating an output file, an executable, and I am just calling it hello because that is, to me, an easy way of naming it. And it compiles it. It takes very little time. And let's do ls. And we now see there's one called hello. And on Kebnekaise, the executable files are marked with a asterisk. There shouldn't be one on this. That's me who have set it wrong, but the same here. But this one gets it assigned automatically. It changes the permissions. And let's try see what the permissions are on these ones here. And here you see hello has an executable bit set here on for the owner. And many of the others don't. And to run it on the login node, which is something you usually shouldn't, because any longer or more resource-intensive jobs should be run on as a batch job, because if you run a lot of stuff on the login node, it will slow it down and it will annoy everyone and no one can work. So don't do that. But these are very, very short jobs. You can run them here on the login node. So let's run hello. So // and then the name of the executable. And that means that you are running it a executable one that is in this directory. And it outputs hello world, just like you expected. So let's try compile an MPI C program instead. And that also is located in this directory. It is here. Otherwise, they can be downloaded also from this text directly, but it's easier to just use the one that already is on your system. And this is a C program, so we use MPI CC, as you can see up here. That is what we need. And we are going to take this program, MPI hello.c, and then I am creating an executable. And just like before, I am just naming it the name of the script, but without the extension. I got a executable. It's marked with an asterisk, so I know it's executable. Like that. And it only says processor 01 hello world because we're on the login node and it's not going to do anything more than that just directly. To do that, you need to add MPI run. If you say MPI run, it will run on all the processors that are available on the login node. And since it's a Skylake node that has 28 cores, it will do 28 instances. You can also use srun. Like this. And in order to use srun, you actually need to give the account because it will do other things as well. So you can't do that on the login node. But if you're doing it in a batch job, you need to use srun. But you can do MPI run here on the login node. Note that if you later load a different compiler than the one this was compiled with, you should recompile it if you're going to run it. It may work, it probably will not, but it may. And you could test to unload this. I can try do that now. And it may or may not work. But let's load instead Intel 2023. If there's one, let's see which ones I have. Let's go with the 2023B here as well. And let's now see what happens when I do MPI run on the executable that I compiled with GCC. And as you can see, it worked, but it didn't work correctly. So something was off. Sometimes it will not work at all. So you should recompile it if you are if you have loaded a different compiler. So for the compilers, there are some commonly used flags. There's the one we just used that we used to create an output file with a specific name. -C, then you compile or assemble the source files, but you don't link it with any libraries. -F, OpenMP, that is for when you want to use OpenMP directives. -G will add debugging informations. And then there are various optimizations from -O to O3, and O2 is the default, which is some optimization, but it doesn't do all of them. And there are situations where the code may actually go slower with more optimizations, but mostly it should run faster. And there are also ways to optimize for specific things like size. And these are all things you can do if you have code you want to optimize. But let's try and compile an OpenMP program. And since we were working with GCC, I'm just going to unload the Intel compiler. So I'm just going to purge everything. And then I will do history to see where I had the other one I was loading. It was FUS 2023B. I'm reloading it. And now I'm going to compile an OpenMP program with F OpenMP, and then the name of this piece of code. And then I'm going to put it in an executable named OMP hello. And now I can run it. And that is not going to be run with MPI run, of course, because it's an OpenMP program. So I'm just going to do / and then the OMP hello. And you can see here, it just sees one thread. You can change it by setting this environment variable export OMP num threads. And let's say we try with 4 threads. And then I rerun it. And now there are 4 threads which each report. And you also get a report at the number of threads are 4, because I asked for that inside of the program. And please try all of these. Let's see how much time we have. We have time to take 2 minutes to make sure everyone has at least tested out compiling something, and maybe compile the OpenMP program and change the number of threads. And you can also try with a different tool chain, but just do this one. Okay, I'm going to continue to talk about compiling with Intel. And we also have Intel compilers at Kebnekaise, and also for Fortran 77, 90, and 95, and for C and C++. And these are the names of the compilers and the MPI compilers. And in order to access MPI compilers, just like with the GCC, you need to load a compiler toolchain that has an MPI library. And let's do that. I'm first going to purge the modules. And then I am going to load Intel 2023B. So module load Intel 2023B. And I will just check what I have loaded. And you can see Intel is loaded, and so is Intel MPI or Intel MKL. So that's fine. We can work with that. And let's try and now compile this code hello.c again. And if you want, you can overwrite it. And I'm just going to name it differently, just for the fun of it. And it just tells me the Intel compiler is deprecated. Just ignore this. And we can now run this here. And I should actually type correctly, and it will work. As you can see, hello.world. Hello world. So just like for C, for GCC, there are some flags or options that you can use with the Intel compilers. There is -fast. It optimizes speed across the entire program. There is -G to produce symbolic debug information. And there are various optimizations. Again, O2 is default, and you can optimize to up to O3. And here, if you're using OpenMP, the option to use is -Q OpenMP instead. And that means that you simply compile it with ICC -Q OpenMP, and then the name of your script, like this. And then you can call it something in your output. You could set it again, OMP hello. And then I'm going to add Intel also, like I did the other time. And it now made an executable here. I'm going to run it. And again, it says the number of threads is 1 because we have only 1. And we can set it again. And then rerun it. And now we have 4 threads. And so each of them reports. And you're also told how many. So that is fine. It works the same way for Intel and GCC. So what about linking? Well, we already linked with the MPI libraries, but what if we want to link with other things? And figuring out how to link with it might be cumbersome. And an easy way of doing that is to use a program called buildenv. I'm going to go back to GCC now. So I will purge this. I will load FOSS 2022B maybe. And then I will load buildenv. And you can see with ML that I have FOSS loaded and I have build-env loaded. And then I will do ML show build-env. And that gives me actually a lot of environment variables. And you can scroll down and find out here how do I link with, say, BLAS. And at some point you come down here to libblas, and it tells you that you could link with -L flexiblas -L gfortran. So you would say GCC and then you would add these libraries here, and then the program you were compiling and the output file if you wanted that. And if you have build-env loaded, you can also use the environment variable that's just called libblas. And you do that by saying $libblas on the line instead. And there's an example here where you'll compile with laypack, and you would do that like this. And if build-env is loaded, you can use the environment variable liblaypack, and that means you just compile like this instead. And that is actually practical because it's less to remember, but it's also you can keep using it even if this changes. So maybe we change it so to use OpenBlast instead, or maybe some other changes, but the environment variable will stay the same. So that is one way of finding out how to link with things. And as you can see here, it also tells you what the name are of the different compilers and things like that. So that's quite handy if you are building a lot of software or just compiling some software. Not all the compiler toolchains have built-in installed for them yet, but you can always ask for it if you need it. And well, I just did this example here, so there's no reason to do it again. But you can also go ahead and try this if you want to, just to see all the many environment variables and see how you need to scroll down quite a bit to see these ones for the libraries. There is a list of most of the installed libraries on Kebnekaise here. So the key points is in order to compile a program, first load a compiler toolchain module. Kebnekaise has GCC and Intel compilers installed. GCC compilers are for RG Fortran, GCC, and G++. Intel compilers are iFort, ICC, and ICPC. Compiling MPI programs can be done after loading a compiler toolchain which contains MPI libraries. And the easiest way to figure out how to link with a library is to use ML show build-env after loading a compiler toolchain.